Hello students, welcome to CHSD Science Lessons. In this video, we will do some topics of P1, which is conservation and dissipation of energy. This is the bigger picture of whole topic, but in this video, you should be able to describe what is meant by energy and law of conservation of energy. And then you should be able to describe how energy can be transferred within the system usefully. And finally, you should be able to describe what is work done by a force. So what is energy? What is it? What does it look like? Where does it come from? So all of these questions in our minds. So energy is an abstract idea. Energy is not something you can touch, or energy is not something you can see, but energy is the capability to do something. So whenever you want to do some work, you need energy. So the definition of energy is the capacity to do work, and it is measured in joules or kilojoules. Joules is joules is SI units and standard international unit, and you can convert kilojoules to joules. So 1 kilojoules equals 1000 joules. Here are some energy stores, so you can discuss with your partners, and let's see how many energy stores you can find out. Right, so well done if you got that. So whenever something is jumping from the height, or it has some height, it has gravitational potential energy store. So everything which is used as a fuel is known as chemical store. You can see battery, you can see acids. Even our food is an example of chemical energy store. When something is moving, running, so it has kinetic energy store. When there is an example of something stretching or compressing, that is an example of elastic potential energy store. Here is, you can see magnets, two magnets are using force of repulsion or force of attraction between them. So this is a magnetic store. When there is an transfer of electrons, then that is the electrostatic energy store. When there is energy transfer, so that is thermal store. Heat energy transfer is another name of the thermal energy store. So this is a nuclear store. Each atom has nucleus in there, and there are some energy bound by the nucleus, so which is known as nuclear store. So there are some basic nuclear stores. In part 2 video, we will be learning about their calculation, and we will be learning about these stores in more detail. So what was the law of conservation of energy? So energy cannot be created or destroyed, but it can be transferred from one form to the other form. So this is important to understand that energy, you cannot create energy, you can produce energy, you cannot finish energy. So whenever there is something happening and energy is being transferred from one form to the other form, so the total energy of the system remains constant, remains conserved. Right, so when we talk about that energy cannot be created, cannot be destroyed, but can be transferred from one store to the other store. So there are 4 key ways of transferring energy between stores. So you can see there in the picture. So one of the energy transfer way is electrical. One of the energy transfer way is waves. So energy can be transferred through waves. Energy can be transferred through heating the particles, and sometimes energy can be transferred due to force, which is mechanical sometimes, or sometimes moving through the distance. Here is an example of a book. If we drop a book from a height onto the table, some gravitational potential energy changes into kinetic energy, and then as thermal energy to the surrounding. So as soon gravitational potential energy is decreasing, the kinetic energy stored increasing. So loss in gravitational potential energy results in gain in kinetic energy. So at the end, the rest of the energy is transferred as to the surrounding as heating or sound on impact. But remember, sound is not the energy. Sound energy is kinetic energy store of vibration of particles. So how might this look like? So we need to find out the pathways of energy transfer. So this pathway will look like it starts from the gravitational potential energy store and it transfer a mechanical pathway, which is kinetic energy store when it was moving. And finally, it transfer to the surrounding as thermal energy stores, but there are two pathways. One is the heating pathway, and the second is the radiation, the wave pathway, which can be sound waves. So energy can be transferred as thermal energy stored through sound waves. So energy transfer pathways always look like, so energy comes in and there is some pathway and energy transformed into some output energy. So this energy transfer could be a single pathway or a double pathway or sometimes triple pathway. So your input energy is transferred to the output energy and it converts from one form to different other forms, but the total energy of the system remains constant. This is the law of conservation of energy. Here is one example of a drill machine. So this drill machine works with the battery and it has some chemical energy stores. So this drill machine converts chemical energy into kinetic energy, into sound energy, and into thermal energy. So it has three different pathways. So one is the kinetic energy is because of the movement. So that is a mechanical pathway. So some sound energy is due to wave and radiation, that is the radiation pathway. And third pathway is the heating through the particles around it. Here is another example of energy transfer. The image shows a battery power drone. Complete the sentences, choose the answers from the box. So you can pause this video for 2 minutes and you are allowed to discuss with your partners and come up with your answers. Here is the answer key. Well done if you got the right answers. Now we will look into the work done. When we talk about work, in normal routine, we talk about, oh, let me do my work. But in science, work done is a little tricky. So work done is whenever a force makes something move, whenever you apply force on something and that object covers some distance, it moves, then in science language, you would be able to say that work is done. On the right hand side of the screen, you can see the equation, the triangle, which will help you to remember the equation. Work done is equals to the force times distance. And very important thing, the distance should be covered in the direction of the force. This is very, very important about choosing the force which is applied, because there are many forces acting on an object, but when you are going to calculate the work done, you have to consider the force which is in the direction of the distance covered by the object. Also, work done is equal to the energy transfer. Whenever there is a work done, energy will be transferring from one form to the other form. And also the unit of the work done is same as energy. Pause this video and discuss with your partners which situation is a harder work. Welcome back. In this situation, there is a trick for you. Maybe some students are thinking that situation 1 is much harder than situation 2, or situation 2 is much harder than situation 1. Before giving you the right answer, I want to show you the direction of the forces. So when something is carrying, its weight is acting always towards downward. But in the situation 1, the student is moving upward. And in situation 2, the student is moving perpendicular to the direction of the weight. So in situation 1, we can say that the direction of the movement and the direction of the force are parallel to each other. So that is the situation where work is done. But in situation 2, there is no work done because the force and movement are not in the same line. They are not parallel to each other. According to the definition I have told you, the force and distance should be in the same direction or in the parallel to each other. There is another example of considering the direction. You can see if a box is placed on the table, its weight is acting downward, its movement is in that direction on the horizontal. So work is only done against resistive force such as friction, not against weight. If we ignore these forces, the work done moving an object horizontally is zero. So if you want to calculate the work done on an object, you should consider the friction force and the distance covered by the object. Here are some drill questions about work done, so you can pause the video for 5 minutes and come up with your answers. Welcome back. Here are the answers for your questions. You can pause the video here and you can mark your answers. So now we will consider here that work done and transferring energy is the same. Whenever there is a work done, energy is transferred from one form to the other form. For example, lifting up an object, when something is you're lifting up, it is gaining some height. So some energy is transferred as a gravitational potential energy. When something is moving, speeding up, when making an object speeding up, so that is the kinetic energy transfer. Making an object slowing down, transfer to gravitational potential energy, object travels upward, and when something is stretched, it has elastic potential energy, and when something stops due to friction, it has thermal energy. There is another example of a woman who lifts up her baby from the floor. The baby weighs 100 Newton. The woman lifts the baby up by 2 meters. In this question, I need to check how much work is done and how much energy is transferred. First of all, I will write down the equation for work done, which is equals force times distance. And force and weight is the same thing. As we know, both have the same units, which is Newton. So 100 Newton is our force and 2 meters is the distance covered. So the total work done is 200 joule. Now the baby has gained 200 joules of gravitational potential energy. So work done and energy gained is the same. The gravitational potential energy equation is just a special case of work done against the gravity. Now putting this example into the practice, you can pause this video here and you can come up with your answers. Well done. So first step of this question, you have to calculate the kinetic energy. And kinetic energy and the work done is the same. So kinetic energy and work done will be 75,000 joules. And then by using the work done equation, rearranging them, you can find out the distance covered before it comes to stop. Well done. If you got the right answer, you can mark your answer, pause this video, and you can mark your answer. There is another example. You can pause this video for next 5 minutes and then you can do your questions. Welcome back. This question is about final energy stores between a ball which is dropped above the floor and bounces back to the portion of its original height, and another ball which is dropped and makes a crater in the sands below. So you have to compare final energy stores. Here is the answer key. You can mark your answers. Well done. If you got all correct, otherwise you can try again. Now I will give you some questions in which you would have three levels. So you can choose your level according to your confidence. If you're confident to use the equation, you can choose the learning part. If you're confident in rearranging the equation, you can choose a challenging part. If you're confident to convert the units into a standard international unit, then you can choose the extra. So I will give you 10 minutes to do all these questions. So you can keep pausing the video and move on to the next question. So you can choose your level and do the question, and you can pause the video and then you can move on for the next question. We will mark the answer at the end. Question number 2 here. You can choose your level and pause the video. Next question. You can choose your level and pause the video. Here are the answers for all of 3 questions for all of levels. Well done if you got all answers correct. If not, you can try those questions again.